Distance time graphs. Always check first. Yes, it's distance, and it's always time for these sort of distance time graphs. It shows a journey, Stephanie's big day out. Now the first thing to do is to fill in the bit of the axes that are not mentioned. This is the time axis. Usually in maths this is the x-axis because it goes across, but it's the time axis in this case. 10, 20, wow, lucky, 30, 40, 50, 60, 70, 80. Okay, time in minutes. Sometimes it's seconds, sometimes it's hours. Minutes is unusual, actually. The distance, 23 miles away to Nina's home. So therefore the distance is in miles. Okay, so what happened? First of all, she walked. Yes, that's a low gradient, slow speed walk. Rest, you go nowhere for, 10 minutes in this case, getting no further away. Then a higher speed run, then another rest. 20 minutes this time. And then even faster on a bike, then more rest, and then even faster on a taxi. Taxi's slightly faster than a bicycle. And then the taxi on the way back home must have taken a motorway. Go. Nina went to Nina's home. Stephanie went to Nina's home. Stephanie took... How long did she take to get there? So she first arrived after 130 minutes. Home. Stephanie. Go on. Next one. She walked for 20 minutes. Walking 20 minutes. Yeah, that was the walking. Stephanie walked 1 mile. Then she rested for 20 minutes. 2 minutes? No. Then she rested for 10 minutes. Something minutes from her home. 1 mile from her home. Okay, so she walked for a bit, then sat down for 10 minutes. Okay, she's not very, very fit. Walking is slow, so the slope is low. Cool. I think that 10 should go just slightly over. What do you think? Editing my book. Rest is a horizontal line. Distance does not change when you are resting. Yeah, we don't say in distance time graphs and speed times graphs. We say rest rather than stationary or stopped. But anyway, rest. Then she ran for 20 minutes. To be how many miles from the start was it? 4. After she ran for 20 minutes. Yeah. Then she rested for how many minutes? 20 minutes. Staying how mile? 4 miles from the start. Then she got her bike and cycled for how many minutes? So during this rest time, okay, she's probably unlocking a bicycle, putting her wheel on, putting the lights on, getting a safety hat on, all that kind of stuff. So she doesn't have to be sitting down. She's just not going any distance. So therefore that's called rest. Then she got her bike and cycled for, how long did she cycle for? 20 minutes. Until she was how many miles away? 10? 9. I think we should have all of those put in from the start. Then it took how many minutes to put a bike in a taxi? 10 minutes. Then she covered the last 13 miles in the taxi because it's 23 miles away to get to Nina's home. Hold on, can you see that? 23 miles to get to Nina's home. Taxis are fast, so the slope is steep. The slopes are called gradients. Fast is a steep line with a big gradient. But Nina's mum said, Nina had gone to Stephanie's home. Oh, should have phoned. Stephanie got back in the taxi, and how many minutes later? 15 minutes later? Hold on, let me show you that. How many minutes later it took? The taxi ride took from 35 to 50, which is 15 minutes. Easiest way is just go 10, 15. Okay. Where am I going? 15 minutes to get back home. In an exam, you have to put in the horizontal dashes and vertical dashes to show that you were using the graph. Oh yes, so I should have had dashes going like this, using a ruler, of course. Okay, that's not too bad. And dashes like this, using a ruler, of course. How's that? Better? Maybe a bit better. Cool, just to show that I was using the graph, not just, guessing or cheating or something. The graph is called a distance / time graph. When you say it, you just say distance time graph. Speed equals distance divide by time. That's what that / means. That / there means divide. Stephanie's average speed to Nina's was, 23 miles. It took her 130 minutes. We need it in miles per hour. So 130 divided by 60 is going to be about 2.2. Divide by 23, it's going to be approximately 10. I'm going to put approximately 10. Write it down in comments down below. Because, yes, obviously she was going about 3 miles per hour with her walking, and maybe 10 miles per hour with her running. Bicycle about 15 miles an hour, and the taxi about 20. So it averages out about 10 miles per hour. Faster equals steeper, rest equals stop, not getting closer to Nina's. Come back equals down. Okay. A horizontal line on a distance time graph means rest, because time is changing but distance is not changing. Rest. Distance. Horizontal. Oh, yes. There we go. Steeper lines mean you're going faster. Okay. Lines going down on a distance time graph means you're going back. Okay. Draw an annotated distance time graph of your journey to school on the back of this page. Oh, well, obviously you can't do it on the back of this page because this is my book and you haven't got my book yet. No, I'm going to publish it. I'm going to put it on Google or Amazon, and probably both. And so, yeah, put your graph down below in amongst the comments. I'll give it marks. I'll tick it. Good. I teach in the schools in Hong Kong, and after school I go to people's homes in mid-levels to teach them maths and science. I also, for people who live outside of the mid-levels Hong Kong area, I do Skype lessons. So if you're in Australia or somewhere, I'll do Skype. I help out with GCSEs, IBs, HSCs, SATs, and A-levels. I couldn't put them all on there. If your mum or your dad wants me to help with your science or your mathematics, they should get in contact with me. Good luck, Gary, HK@gmail.com. Bye!